Sample size for estimating a proportion, our tutorial. In Allison's lecture, you learned how to calculate the sample size required if you wish to create a confidence interval for a proportion for varying confidence levels and margins of error. In this tutorial, we will use R mostly as a calculator, but also to be able to find critical quantile values from the standard normal distribution. Let's remind ourselves of the formula for finding the sample size. Suppose we wished to estimate p to within 3% with a 95% confidence interval. How large of a sample size would we need to be able to do this? We know that for a more conservative estimate, and of course for the maximum margin of error, we should let p equal to a half. We'll let the margin of error equal to 3% or 0.03. Now to find the value z alpha over 2, we know that for a 95% confidence interval, alpha equals to 0.05, so alpha over 2 is 0.025. Using the Q-norm function, we can find this value to be approximately 1.96. Finally, the sample size required is approximately 1,067 subjects. If we wanted to have a smaller margin of error, say 1% or 0.01, we can see that the sample size required is much bigger, 9,604 subjects. This makes sense since a narrower or more precise confidence interval requires more data. What if we wanted a higher confidence level than 95%? Say we wanted 99%. Well, for a 99% confidence interval, we know alpha is 0.01, so alpha over 2 is 0.005. Our new value for z is 2.576, leading to a much bigger sample size of 16,587 subjects. So we can see that if we want to be more confident, we again require an even bigger sample size. Increasing the confidence level or the precision of a confidence interval requires additional data, which means a bigger sample size. But a larger sample size has its drawbacks. So there's generally a fine line between how big of a sample can be collected and how confident we can be in the results.